All right, next up we'll look at question 3, parts E through H. And in part E, we see 3 over AB squared plus 5 over ABC. And these denominators are not the same. And so for that, we're going to have to start by finding the least common denominator. All right, so as we've been doing the last couple videos, we'll first just lay out each of the distinct factors. So we need an A, a B, and a C. And then for the exponents, we'll just take the highest exponent that each individual factor appears to. So here, notice there's this b squared right there, so I'm going to need a b squared for the LCD. And then A and C, they just show up to the first power, and so we'll just have an A and C for the LCD. All right, so now what we're going to do is rewrite each fraction so the denominator is equal to this LCD. So I'm going to have a b squared c and a b squared c. And so now to rewrite each fraction, I'm going to go ahead and just figure out what's missing, right? So from ab squared to ab squared c, I'm missing this factor of c. So I multiply top and bottom by c. I'm really just multiplying by 1. And that's going to give me 3c there on top. Okay. For 5 over ABC, well, I'm missing here a b. So I'll multiply this by b and this by b. And that's going to give me a 5b. And now I can go ahead and just combine numerators. I have 3c plus 5b. And then that's all going to be divided by that common denominator of ab squared c. All right. For part F, I have 2 over x plus 1 minus x over x plus 1 squared. And so again, these are not the same denominator, so we'll go ahead and find the LCD first. And so my factors here are, well, x plus 1. And then for the exponent, since x plus 1 shows up as a square in the second denominator, I need an x plus 1 squared for the LCD. So then I'm going to go ahead and rewrite each fraction. And so it's going to have this common denominator x plus 1 squared. And for the first fraction, to go from x plus 1 to x plus 1 squared, I need to multiply by x plus 1. All right, so that's going to give us 2x plus 1 up in the numerator. And notice for the second fraction, it's already set up for us. I already have that denominator of x plus 1 squared, so that would just be x. All right, so now we can go ahead and combine numerators. So I have 2 times the quantity x plus 1 minus x, and then I'm dividing all of that by this common denominator of x plus 1 squared. And then to finish, do that over here, I'll go ahead and just open up parentheses and combine like terms. So just distribute that 2, and we're going to get 2x plus 2 minus x all over x plus 1 quantity squared. And then finally 2x minus x, that's just going to be x, and then we have a plus 2, and then we're dividing by x plus 1 squared. Okay, so that does it for that problem. For G, notice, hey, I do have a common denominator. That's nice. And as we noted in the last video, when you have a subtraction here, and then you have more than one term up in this numerator, this subtraction is applying to each term in parentheses, right? So it really distributes there to each. So that's the main thing to be careful about for a problem like this. So I'm going to get x minus x plus 2 over this common denominator of x minus 3. And the x's here just drop out, which is nice, leaving us with this 2. in the numerator. So we get 2 over x minus 3. All right. Great. And then for the last one, h, x over the quantity x squared plus 3x plus 2 minus 3 over 2x plus 2. Well, we need to build an LCD because we don't have a common denominator. And in order to do that, since these are not in factored form, our first job is to factor them. So I'm going to go ahead and factor this denominator as the product of two binomials. I'm going to need an x plus 1 and an x plus a 2. And then for this second denominator, there's a common factor of 2 there, so I'm going to factor it out, and that's going to leave us with an x plus a 1. And so then for our LCD, I'm going to need a 2. I'm going to need an x plus 1. And I'm going to need a x plus 2. Okay. And since everything just appears to the first power, everything will appear to the first power for the LCD. All right. So now let's go ahead and rewrite each fraction so it has this common denominator. So 2 times the quantity x plus 1 times x plus 2, and then 2 times the quantity x plus 1, x plus 2. All right, and so for the first fraction, what am I missing? Well, I'm going from x plus 1 times x plus 2 to 2 times x plus 1 times x plus 2. So in fact, all I'm missing here is the factor of 2. Okay, so I'm going to multiply this by 2 and the x up in the numerator by 2, and that's going to give us 2x. For the second fraction, well, I'm missing the x plus 2 factor. So I'm going to have to multiply this by x plus 2 as well as the 3 up in the numerator. So that's going to give me 3 times x plus 2. Okay, great. So now we can go ahead and combine numerators. So I'm going to get 2x minus 3 times the quantity x plus 2. And then we're dividing all that by that common denominator, 2 times x plus 1 times x plus 2. We're getting there. This one's a little bit longer. And go ahead and distribute this negative 3 next. And so that's going to give us 2x minus 3x minus 6. And then divide all of that by that same denominator. And then we can finish up over here. 2x minus 3x is minus x, and then minus 6, and then we're dividing all of that by 2 times the quantity x plus 1 times the quantity x plus 2. Okay, and that's going to do it. Now, you could multiply this denominator out if you so desired. There's absolutely no reason to do so, and in fact I would encourage you just to leave it in factored form. Okay, so I did want to point that out because it's a pretty common question. Okay, well that's going to do it. I'll see you in the next video.